Okay, so our next one gets to be a little bit confusing because of the equations. We start talking about less than, more than, and that can be kind of difficult for people to set up. So let's go into the example and try to make it so it's not as difficult. It says Mr. Pacina is using 2 grills to prepare chicken for a chicken plate fundraiser. I was out and about today. I saw 3 different sales of these chicken plates. At any point in the grill time, the first grill holds 8 pounds of chicken less than the second grill. If Mr. Pacina is currently having 48 pounds of chicken on the 2 grills, how many pounds of chicken are on each grill? We have 2 grills going on, so we're going to have 2 variables. I'm going to call it X and Y. Okay. And it asks us how many pounds of chicken are on each grill. So I'll let X be pounds of chicken on grill 1. And then Y would be pounds of chicken on grill 2. Okay. Since we have labeled our variables, let's go back through and write our equations. All right, Mr. Pacina using 2 grills, chicken plate. That first equation or first sentence, not equation, just gives us background. Don't need it. At any point in the grill time, don't really care. Here we go. The first grill or grill 1 was X. So we're going to have X holds, X has, X is. Whenever you have one of those verbs, that means equals. So we have the first grill, X, holds equals 8 pounds of chicken less than the second grill. So we know less means subtract, but if you're trying to write it as 8 minus Y, this says that Y is less than 8. So you have less than 8 pounds on that second grill. And this is Y is less than 8. So that's not quite what we want. Instead, what we need is the second grill minus our 8. That's how we got the first grill holds 8 pounds less than the second grill. Let's get another equation. Mr. Pacina currently has 48 pounds of chicken on the 2 grills. So altogether, X plus Y, we have 48. Because we are solving this using matrices, we need to do something to the first equation. The first equation is not written in standard form. Now, technically, could you solve this by plugging in the Y minus 8 into the second equation for X and using substitution? Yes, absolutely. But we're in the matrices unit, we're doing matrices. Going to continue to do them. Okay, so that first equation, we need to move our Y over to the left-hand side to be in standard form. This means that we're going to have X minus Y, because we're subtracting Y from both sides, is equal to -8. Don't drop your signs. Second equation is in standard form already, so we are good to go. And I know you're thinking, great, now I can use addition elimination, just get rid of the Y's. Well, yes, technically you could, if we weren't in the matrices unit. And since we are in the matrices unit, you're going to write this in AX equal to B form. Remember, if you cannot see a coefficient in front of any of your variables, it is a 1. So this time A, top row is 1, -1, because we have minus Y. And bottom row is 1, 1. We have 2 equations with 2 unknowns, so A is a 2 by 2. X is going to be our variable matrix XY, and B is our constant matrix, what we are equal to, which in this case is -8 and 48. Remember to solve this. AX equal to B. X is equal to A inverse times B, which means that we can use Kramer's rule to find A inverse because we have a 2 by 2. It's 1 all over the determinant times our crazy matrix, where we flip-flop A and D, and we negate on the backswing, negative B, negative C. If we label our elements in matrix A, we find out that we are going to have 1 all over A times D, so 1 times 1, minus B, which is negative 1, times D, which is, or sorry, times C, which is 1. 1's everywhere. Times our crazy matrix, where D and A flip-flop, and we negate on the backswing, so C becomes negative, and since B was already negative, it becomes positive. Watch your signs when you're working with that fraction, because in the bottom, when we subtract a negative, it means that we're adding a positive, which means you should have 1/2 times our crazy matrix. And when you distribute this, we find out that A inverse is equal to, top row is 1/2, 1/2, bottom row is negative 1/2, 1/2. And now that we have found A, we can find X, because remember, X is equal to A inverse times B. We just found A inverse is the matrix with all the halves, except the bottom one is a positive. Sorry, is a negative 1/2 in the bottom left. Everybody else is positive. And we're going to multiply that by B, our constant matrix, what these guys were set equal to. We have a 2 by 2 times a 2 by 1, which means we're going to wind up with a 2 by 1. So I need 2 rows, 1 column. So I'm putting a line just to separate my rows. It keeps my work a little bit more organized. We have 2 rows that we're working with. The top one is row 1, the bottom one's row 2. And we have 1 column that we're multiplying from B. And remember, you don't have to label these like I do in the purple and green. It's just there to help you if you would like that guidance on your multiplication. Remember, we multiply the first 2 together and add the second 2 multiplied together. So row 1 times column 1, we get 1/2 times negative 8 plus 1/2, the second 1/2, times 48. Because we have finished row 1 through column 1, we get to go to row 2. First is negative 1/2 times the negative 8. And then we're going to have plus 1/2 times the 48. Remember, if you've done the multiplication correctly, what is in the parentheses should line up. And we wind up getting 20 up top, 28 down below. You're not going to leave your answers like this. Remember, this is our variable matrix, little x, little y. And you need to explain what this means. So x is equal to 20 pounds of chicken on the first grill, or grill 1. And y is equal to 28 pounds of chicken on grill 2. And if you double check this real quick, just mentally, in our original equations, it said grill 1 held 8 pounds less than grill 2. So there's 28 minus 8 gets us 20. So that one works. And altogether, we had 48 pounds. 20 plus 28 gets us those 48 pounds of chicken that he is currently grilling.